Hello student. Today's topic is routing. Routing means when the packet is sending from one router to another router, what how the packet is transferred or what is the way of transferring the packets from a router to router so that packets will be transmitted from the transmitter and means sender, and it is received at the destination. So routing is a process of selecting the best path in the network. In the path, the term routing also meant forwarding the network traffic among the networks. However, the latter functions is better described in the forwarding. Routing is performed for many kind of network, including the telecommunication network, electronic data network such as internet, and the transportation network. This article is connected primarily with the routing in electronic data network using the packet switching technology. In packet switching technology, route direct packet forwarding through the intermediate node. Intermediate nodes are typically a network hardware devices such as router, bridges, gateway, firewall switches. General purpose computer can also forward packets and perform the routing through they are not specified hardware and may suffer from the limited performance. Means what? See here. The essential of traditional routing protocols. There are two types of routing protocol so that we can find out the shortest path from the sender to receiver. Link state routing protocol. It is also called as a unicast routing, or it is also called as a Dijkstra algorithm and distance vector algorithm. Okay. Then link state routing protocol, that is also called as unicast routing. Unicast means one one node to another node. Data is flowing. That is called as unicasting for forwarding. Then unicast. Unicast means transmission from the single transmitter to the single receiver. It is a point to point communication between the sender and the receiver. There are various unicast protocols such as TCP, HTTP, etc. TCP is the most commonly used unicast protocol. It is a connection oriented protocol that rely on the acknowledgement from the received side. HTTP start HTTP stand for the Hypertext Transfer Protocol. It is an object-oriented protocol for the communication. Now, features of link state protocol. Link state protocol is a small packet that contain the routing information, because when the packet is transferring from one router to another router, so what is the route, what is the who is the sender, who is the receiver, all this information should be there. That is a link state packet. Link state database is collection information gathering from the link state packet. Shortest path first algorithm, the calculation performance on the database result into the shortest path. Routing table is a list of known path and the interface. Calculation of the shortest path. To find out the shortest path, each node need to run the famous Dijkstra algorithm. This famous algorithm used for the following steps. So uh, theoretically, what are the steps we will see, and actually after that we will explain with example the Dijkstra algorithm. First step, the node is taken and choose a root node of the tree. This creates the tree which is a single node, and now set up the total cost of each of the nodes to some values based on the information in the link state database. Then state stage 2. Now the nodes select one node among all of the nodes not in the tree, like the structure which is nearest to the root, and add this to the tree. The shape of the tree get changed. Then after this node is added to the tree, the cost of all the nodes not in the tree need to be updated because the path may have been changed. Step 4, the node repeats the step 2 and step 3 until all the nodes are added in the tree. This is the example from which we can understood the link state routing protocol, Dijkstra's algorithm. Okay. This is the example where A, B, C, D, E, F are the nodes and they are connected to each other with the help of a link. And for each link there is a cost. Cost means we can say in the form of suppose distance. As distance is large number will be taken, but it is not an exact meaning of the distance. Here we can say as a cost. Okay. So first of all, what we are doing? First of all, we are performing the tables. Table consists of node and the cost. Each table consists of, for each node, there is a one node and one cost table. So, with respect to the A node will be connected, directly connected to the B, C and D. After that, E and F is also connected to the E, but it is connected through the different nodes. That is, E can be connected through the B. So that is not called a direct connection. So A will connect directly to the B, C, D. So these nodes are direct connections having the cost is 352. Same case for the B also. B is direct connected to the A, D, E. Then E is connected to and with the cost 214. Likewise, E is connected, sorry, this one is connected to the A, B, E and C. Then E node will connect to the B, D, F with the cost 432. E is connected to only two node C and E with the cost 1 and 2. And lastly, C is connected to A, F, D with the cost 2 to 1. Okay, so these are the tables are complete. Now, by using this algorithm, we are maintaining one table in that there is the iteration, tree and the nodes. So, in iteration means one by one which steps we are following, that is nothing but the iteration. Trees is nothing but from which node we are starting and one by one nodes are added to this one. So, it is just like the tree and there are different nodes that is connected to in the main node. So see here, with respect to the A, we are calculating all the distances. Means our task is from A when we are moving to at point B, at point C, at point D, at point E, at point F, so that we are getting the shortest distance. Means for example, if we are starting from the A and our end point is F, so there is a too many directions. So one is a from ACF, that is a 3 cost because 2 plus 1. Then from ADEF, which is having cost 8 plus 2 10. Then ABEF, that is 9. So there are a different cost, but our target is we are finding out the shortest path distance. So from A to F we have only one shortest path, that is 2 and 1. Okay. Okay, so we will start with the node A. So we are writing in the initial iteration node A, and after that whatever the nodes are remaining, they are written here B, C, D, E, F. Okay, so in the first iteration, see here, this A is directly connected to the B, C, D. B, C, D. So we are writing here, from the A, the distance for B is 3. Then for C, it is 2. For D, it is 5. Okay. After that, A is not connected to the E and F. That is why we are putting here infinity, and this is also an infinity. Okay. Then, if we complete this task, then we are circle to the cost where whose value less. So from this row 2 is the lowest value. That is why we are taking C node here, because having the less cost. So A comma C. So while writing A, so C is the, we are visited up to the now C, because C is the shortest distance. So we are taking dash here because we are visited. So after visiting, it's C to C, it is 0. That is why no need to write the things. Okay. Then after the C point, we can reach at the point F, we can reach at the point D. Only 2 points we can update. So from A to C, we are going to D with the value of 4. So previous one, A is directly connected to the D with the value of 5. And when we are moving from A, C, D, its cost is 4. That we needs, means a lesser path should be required. So here we are writing as a 4. Okay. Then C is connected to the F. So what is the distance? How much is the distance? 3 plus 2. 3 plus 1, that is 2 plus 1 is 3. So this 3 is here. So we are writing here a 3. So we are writing here a 3. Okay. After that, we may take any one of this one. So now we are taking this B3 value because it is a lesser. We can take this B or this F also. One only one at a time. That is why we are selecting as a B. So we are writing here and C is already in the tree. Now we are adding B also. So A, B, C. So when we are visited to B, write a dash. Then we are already visited to C. Now from B, B is directly connected to the D with the help of 4. 4 cost, and this one is also 4 cost. So we are writing 4 as it is. Then from B to E, we required a 7 distance. So we are writing here 7. We cannot reach from B to F. That is why it is an infinity. Okay. Okay. Then from this one, we have a lesser value is a 3. So we write here A, B, C already, and because of the lesser cost for F node, that is why F is written over here. Then after this, what happened? We are visited B, we are visited C, we are also visited to F. Now what are the point is remaining? If we are visited to F, if we are revisited to F, then there are 2 points. C is already visited, so E. So we are reaches to the E by 5 points, because 2, 1 and 2. So it is a 5 value. So previous it is a 7, now it is a 5. So we are writing here 5 here. Okay. Among last one, then 4 and 5, this 2 cost is remaining. Among this, 4, 1 is a lesser cost. That is why we are taking D here. So A, B, C, D, F, and we got the value of D. From after D, we already visited all the nodes. That is why we are keeping the value of 5 as it is. Now lastly, we are adding with the E value, and we are writing all the values. So while observing these things, one by one we are adding the tree. And we are getting the distance, smallest cost of the devices. So from this is our given diagram. From this one, we are getting from the started from the A point. So A to C is the shortest distance. So A to C we can move with the value of 2. Then A to D we can move A to D by number of ways, but 2 plus 2, 4 is the shortest distance. Okay. From A to B we have a 3 distance. Then A to F is the shortest, is the 5 distance. Then A to F is a 3 distance. So this diagram tells us a shortest path from A to each of the devices. Okay. 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 This is about the link state algorithm or Dijkstra algorithm. Thank you.